Alright, my dear children of class 11 science, we will move to the next numerical problem, problem number 3, and this is actually a problem based on Stefan's law, okay, that you have learned in case of black body. Okay, now problem number 3 says that a black body has temperature. A black body has what? Temperature, which is of 1527, okay, 1527 degrees Celsius. So what is the temperature of black body? 1527 degrees Celsius. So let me start doing the solution of this question. So I write down the temperature of the black body. T means how much? 1527 degrees Celsius. But children, we convert this temperature from degrees Celsius to Kelvin, because whatever temperature we use and the formula we use, we keep the temperature in what unit? SI unit. So to convert from degrees Celsius to Kelvin, what you need to do? You need to add 273. Okay, 273, and that will be in what? Kelvin. So this will be in Kelvin. So 1527 plus 273. If you add, it will be how much? 1800. This value, if you add, it will be 1800 Kelvin. Okay. So what is the temperature of the black body? 1800 Kelvin. Now the surface area, this black body even has a surface area that is 0.2 meters square. The surface area I write by letter A. A is the surface area of black body, which is 0.2 meters square. Okay. Now question says that find the energy radiated per second. You have to find the energy radiated per second, okay, by the black body. Now to calculate the energy radiated per second by the black body, okay, so we have a formula. Okay, and the formula is given by which law? Stefan's law. Okay, now according to Stefan's law, and children, according to Stefan's law, the radiant energy, as you have learned already, the radiant energy emitted per second, listen carefully, the radiant energy emitted per second per unit area of a black body is given by Q, and this Q equals to sigma T to the power 4. And you know what is sigma out here? Sigma is Stefan constant, where sigma is what constant? Stefan constant. Stefan's constant. Now this value is given. In the question, the value of Stefan's constant is given. But actually you need to find the energy radiated per second. Now this is actually energy radiated per second per unit area of a black body. So to calculate the energy radiated per second, okay, so what I do? I write down, therefore, energy radiated. Okay, therefore energy radiated per second of a what body? Black body. Of a what body? Black body. And that energy rate per second of a black body is equals to sigma T to the power 4 into A. Sigma T to the power 4 into A. Because Q equals to sigma T to the power 4 is the energy rate per second per unit area. So out here we need to calculate energy radiated per second only. Okay, so that we need to multiply this energy by area. So it will be sigma T to the power 4A. Okay, where A, as you know, it is the surface area of the black body. So surface area of black body is already known. So let me just substitute the value and calculate, because Stefan constant is already given, which is 5.67 into 10 power minus 8. The temperature of the black body we have already calculated, and that is 1800. This is 1800 with 10 to the power 4. Okay. Now A, the area is also given, that is surface area is how much? 0.2. Okay. Now we need to open the bracket and multiply. So it will be 5.67 into 10 to the power minus 18. Now 1800 square to the 10 to the power 4 means I can write this way also, like 18 into 100. 100 means 10 to the power 2 with whole to the power 4 into 0.2. Okay, so 5.67 into 10 to the power minus 8. Now 1800 square. Now we need to do 1800 square. So 1800 square 10 to the power 4. Sorry, not square. 1800 to the 4 means 1800. 18 into 8. 1800 sorry to the 4 means 18 into 18 into 18 into 18 into 10 power 2 to the 4 means 2 4s are 8. Power is 8 into 0.2. Now this power minus 8 and plus 8 become what? 0. Okay, minus 8 plus 8 means 0, means 10 to the power 0. So it will be 5.67 into 0.2. So this is 0.2. Then there are how many 18s? 4 18s. 18 into 18 into what? 18. And definitely 10 to the power minus 8 and 10 to the power plus 8 means minus 8 plus 8 becomes 0, and any base 10 to the power base with 0 means 1. Okay, now with the help of calculator, children, we can have the calculator. If you multiply these all quantities, okay, you get the value approximately as 1.19. I am writing in 2 decimal place into 10 to the power 5. So I am just writing directly the value, but you can check with the help of calculator. Multiply all this quantity. Okay, so the energy radiated per second of a black body is 1.19 into 10 to the power 5, and the unit is what? Joule. So how much energy that is radiated by the black body per second? Only in 1 second, that is 1.19 into 10 to the power 5 joule. So this is one of the numerical based on Stefan's law. Okay, now this is problem number 3. Now I'll be solving next problem, that is problem number 4, and that is also based on Stefan's law. And children, problem number 4 now we are going to solve, and this problem says that at temperature 27 degrees Celsius, a black body is emitting heat at a rate of 3 into 10 to the power 5 joule per second meter square. Means this is the amount of energy radiated per unit area per second from a black body. Okay, and this heat which is radiated at temperature 27 degrees Celsius. The question says that at what temperature will it emit, means the same black body emit heat at a rate of 243 into 10 to the power 5 joule per second meter square. Now to calculate the temperature of a black body, okay, when the amount of heat radiation is given, okay, then we can use definitely what? Stefan's law. So we can use Stefan's law, but according to Stefan's law, the amount of heat, I don't know from what? Stefan's law. I write directly from Stefan's law. The amount of heat, the radiated per unit second, per unit area, okay, of a black body is given by Q equals to sigma T to power what? 4. Okay, sigma T to power 4. And where out here, sigma is simply called what constant? Stefan constants. This is Stefan's constant. Where Q is the amount of heat, okay, radiated per unit area per second of a black body, and this is also called the rate at which the heat is radiated, okay, from a what body? Black body. Now, but there are two different temperatures in which the amount of heat which radiated given. So this is at a temperature say 27 degrees Celsius, but from 27 degrees Celsius the temperature can be raised. But one thing you need to keep in mind, that when more amount of heat radiated from a what? Black body, more is the temperature of that black body. Okay, because heat radiated and the temperature are directly proportional to what? Each other. Because this radiated amount of heat which radiated is more than this amount of heat radiated. So definitely the temperature in which this amount of heat which radiated will be more than this temperature, that is 27 degrees Celsius. Okay, now in this question I write down, since the temperature is the temperature of a black body, okay, the temperature of what body? The black body is raised from T, and this temperature T to what? Say T dash. I am writing T dash. So when the temperature of black body is raised from T to T dash, then the new what? Rate of emission. I don't know, new rate of what? Emission of radiation. New rate of emission of what? Radiation from a black body is given by Q dash, and this Q dash equals to what? Sigma T dash to the power what? 4. So children, just try to understand this two relation. This is also Stefan's law, this is also Stefan's law. But this Stefan's law measures the amount of heat radiated per unit area per second at temperature T, And this is also Stefan's law, that also measure amount of heat radiated per unit area per second at temperature T dash. Okay, now in this question, sigma is constant, but whatever amount of heat which radiated from a given black body, this sigma value will remain what? Constant. Okay, so with this relation, we can calculate the temperature or the new temperature. Okay, so and children, your value of Q and is already given in the question, and this is how much? 3 into 10 power what? 5 joule per second meter square. Okay, now this heat which radiated at temperature that is 27 degrees Celsius. Now 27 degrees Celsius means how much? 27 plus 273, which is how much? 300 Kelvin. Okay, 300 what? Kelvin. Now next is the heat which is also given, that is Q dash, that is how much? 243, yes, 243 into 10 power 5 joule per second meter square. But this heat which radiate at temperature that you don't know, so that temperature we need to calculate. So let me just give this as question mark. So at what temperature the heat which radiate from the black body is 243 into 10 power 5 joule per second meter square, and that temperature we need to calculate. Okay, so in order to calculate the temperature, this particular temperature, I use the relation, and the relation is what? Q equals to sigma T to the power 4. Okay, let me just give this as question 1, and Q dash is equals to sigma T to the power sigma T dash to the power 4 1. So these are the two equations which I formed from Stefan's law. Now what I do, I divide equation 2 by 1 both sides. So I write down this way, dividing equation 2 by 1 both sides. Okay, so if I divide equation 2 by 1 both sides means I divide left hand side, I divide right hand side. So left hand side of equation 2 is Q dash by left hand side of equation 1 is Q. So Q dash by Q equals right hand side of equation 2 is how much? Sigma T dash to the 4 by right hand side of equation 1 is how much? Sigma T to the power 4. So this sigma now cancel out. Okay, now let me just write this relation as T dash to the power 4 by T to the power 4 equals to sigma dash by Q dash by Q. Now actually we need to find T dash. So but this T dash and T has same power. So can I write this way also? T dash by T with whole to the power 4 equals to Q dash by what? Q. Q dash by what? Q. Now to calculate T dash, now I have to eliminate 4. Now from left hand side, if I eliminate 4, so on the right hand side it will be 1/4 of Q. Okay, so it will means I write down this as T dash by T equals to Q dash by Q with power 1/4. So if we remove 4 from the left hand side, on the other hand you have to give 1/4. Now we can easily calculate. So I'll make first T dash as the subject. So T dash, well, now it will be T into Q dash by Q with power 1/4. Okay, so T, the value of T is how much? 300. Q dash, the value of Q dash, yes, is also known, 243 into 10 power 5. The value of Q is also known, that is 3 into 10 power what? 5 with power what? 1/4. So 10 power 5, 10 power 5 cancel out. Yes, we can even divide this quantity. 3 1s are 3, 3 8s are 24, and 3 1s are 3. Okay, so now it's coming 300 into 81 to the power 1/4. And children, you have done exponent in class 7, 8 and on. So 81 to the 4 can be written this way also. 300, 81 can be written as 3 to the power 4 with 1/4. So this 4 and 4 cancel out. So which means it is 300 into 3. Okay, now 300 into 3 means nothing but how much? 900. And this is Kelvin. So temperature is how much? 900 Kelvin. But as the question in which the black body temperature which was given how much? 27 degrees Celsius. So I can convert this Kelvin into what? Degree Celsius. So what you do, you just subtract by 273. So 900, okay, minus 273. If you subtract, means we can write this temperature in what? Degree Celsius, which means it is 627 degrees Celsius. So look at the temperature of black body, which is 627 degrees Celsius. At this particular temperature, that black body emits radiation how much? 243 into 10 power 5 joule per second meter square. So this is also one of the numerical based on Stefan's law. So there are still 2 more numerical to solve, and with that your chapter heat transfer get completed, and that you learn in the next YouTube video.